Today we're going to be talking about graphical transformations. Different forms of transformations would be things like translations, reflections, and we're going to take a look at what it looks like as far as function notation goes. So translations, those are just your shifts left, right, up, down. So your horizontal translations versus vertical translations, things you want to be aware of. When you're working with horizontal translations, you're going to see the change happening within that value, that x value, that factor, that f of x. So when you see a value either added or subtracted inside that parentheses, you're going to think it's a horizontal translation. Now, it almost looks a little opposite from what we would think. So when you see a negative c or a negative number, it's moving to the right. And when you see a positive number, it's moving to the left. So I feel like that's a little bit backwards from like a normal intuition. Those are just going to be your horizontal shifts. Vertical shifts, those are going to come after the function. So I can see f of x plus c, f of x minus c. And your vertical translations, these are going to work like we would expect. A positive motion, we would think it would be an up motion, and your negative motion, negative c value, is going to be down. So the one big thing we're going to notice with these is typically your horizontal movements, they're always going to be opposite of what I think is our normal thought process. Where your vertical movements, these are going to be normal, or what we would expect to have happen. So if we look at a couple examples below, so we're going to describe how the graph of the absolute value of x can be transformed to the graph of the following. So if I'm looking at this first equation, I see the difference between the absolute value of x and our first example is this minus 4. And since it's coming after the function, that's telling me it has to be a vertical change. Since it's vertical, I think it's a normal transformation. I think it's a negative 4, which would tell me it would shift down by 4. Okay. Taking a look at B, now I'm noticing instead of absolute value of x, it's the absolute value of x plus 2, where that plus 2 is happening within that factor. So I am thinking, okay, since it's inside, that's telling me horizontal. Since it's horizontal, I want to think opposite. So if I'm thinking it looks like a positive 2, it looks like it would go to the right, it's going to go backwards. We're going to think shift left 2 units. Okay. Now we get into other things such as reflections. So we have just some basic, almost going back to geometry, points x, y. And the points x, negative y, they're reflections of each other across the x-axis. So if you are negating the y value, we're thinking flip across the x-axis. Maybe a visual to go along with this. You have any coordinate, we'll say here's your coordinate, call it x, y. And if I'm flipping this across the x-axis, well, I'm still going to go over that same x amount, but now instead of going up positive y, now I'm going to be going down a negative y value. Okay? If we move on, points x and y and negative xy are reflections of each other across the y-axis. So again, if I do that same idea, but think this time I'm going across the y-axis, well, now I have to change the direction of x. So instead of going to the positive motion, now I have to go to the negative motion, negative x value, but I would be going up that same positive y value. Okay, so what does it look like as far as function notation? Well, function notation, if we're going across the x-axis, and I want to think our notation. So across the x-axis here, it looks like positive y went to negative y. Notation, in order to show that, think negative y value, that's like negating the entire function. So it would be like distributing a negative across the entire function. Versus if we go across the y-axis, the only thing that's changing is our x-coordinate. So function notation, all I would see is anywhere I see an x, now we're going to make it a negative x. Okay, so on the next page, we're going to take a look and actually practice these. So we're going to find an equation for the reflection across each axis. So first we're going to start with the x-axis. If we're reflecting across the x, we're thinking negate the y, think negate the entire function, or distribute a negative. Now, when we do this, we could actually have two different answers. So the first thing I'm going to do is start by showing that I want to put a negative to the entire function. I want to distribute that negative to the entire thing. Now, options that we have, you can either distribute the negative to the top, to the numerator. If we did that, my numerator now becomes negative 5x plus 9. I'm not going to distribute it to the bottom. Keep in mind, if I distributed two negatives, that becomes a positive. I haven't changed anything. So when you're distributing a negative to a fraction, it's either the numerator or the denominator, not both. So there's an example of how we could get this to be reflected across the x-axis, distributing to the numerator. If we distributed this to the denominator, so keep in mind, numerator now isn't going to change, the denominator will now have the negative shown. So either of those would give you that function reflected across the x-axis. If we were to reflect across the y-axis, now we have to think, okay, notationally, I would have negative x. So anywhere I see an x, I make it negative. So I go into our function, into our f of x function, and I see an x, I make it negative. To the bottom, I see an x, and I make it negative. Keep in mind that negative is within the parentheses, so I am squaring that. When we simplify this, now we're going to have a negative 5x minus 9, and on the bottom, when I square a negative, it becomes positive. And that would be the equation to reflect that over the y-axis. Okay, and the last transformation that we get, this is probably our most difficult one. These are horizontal stretches or shrinks. And probably the more difficult one is the horizontal. Just like we said before, horizontal, I'm just going to say probably opposite of what you would think or what you expect. So when you think it looks big, it's going to get small. When you think it looks small, it's going to look big. Okay. Things that we want to keep in mind, again, if you take a look at this notation, it's just the x value that we're going to see changes happening to. Different from your vertical stretches or shrinks. So again, like we said before, vertical, it's kind of normal. Or maybe what you would expect. And again, looking at the notation, so I'm seeing c times this whole function. So it's going to the entire function, whole function change. Okay. So we're going to try a problem down here. Now, first thing that we have is we have a curve. Our function that we're looking at is this function right here, x cubed minus 16x. And we want to do a vertical stretch by a factor of 3. So if I'm looking back up here, a vertical stretch. So vertical, we're thinking whole function. Stretch by a factor of 3. Now 3, big number, so I'm thinking it's going to look bigger. This is telling me I'm going to put the 3 in front of the entire function. So I would have something that would look like 3 times the quantity f of x. So if we were to actually write that out, that would be 3 times x cubed minus 16x. And if I wanted to simplify this down to form this function c2 that they're looking for, that would turn out to be 3x cubed minus 48x. So we can see again, it's happening to the entire function. It's supposed to get big. It looks like it gets big. Nothing crazy there. Okay. More difficult one is going to come for letter B. So it says we're going to do a horizontal shrink by a factor of 1/2. So when we do this, I almost want you to think again, think big. So if I see a small number, I want to think opposite because I'm doing a horizontal motion. and I'm thinking only my x values. Okay, so let's go back to that opposite. What do I mean by opposite? Really, I'm thinking like reciprocal. So I'm thinking opposite or the reciprocal, okay, when we do this transformation. So in order to do this, the notation up above says I would take f of x and divide it by my c value, or 1/2. All right, well, if I have a fraction divided by a fraction, if we simplify that, that's that whole copy, change, flip process. So if I copy, change to multiply, and I flip that fraction, notice how I'm getting that reciprocal of what we started with. Okay, and it's only going to my x values. So if it's only to the x values, wherever I see an x, I would replace it with 2x. Okay, so we start off and we have 2x cubed minus 16. Here's an x, replace it with 2x. Now we can simplify this down. So 2 cubed, we're going to have 8. Don't forget, cube your x. And over here, if we distribute through, we're going to have minus 32x. Okay, so now we're not going to have them separate. Typically, we're going to have to combine some transformations. And you just have to be careful of the order and how they're doing the order. So if we take a look at 4, we're starting off with the graph of y equals x squared. And it's going to undergo the following transformations in this order. So we're going to do this step at a time. So the first thing says we are going to do a horizontal shift 2 units to the right. So horizontal, thinking opposite, 2 units to the right. So I want to think, well, if I thought right, I'm thinking positive, I really want it to go opposite, think negative. So this first step here, if I were to call this step 1 would take our function, and again, horizontal is all with the x's, backwards motion. There's a horizontal shift 2 units to the right. Okay, our vertical stretch, well, vertical is normal, and if it's a vertical stretch, so different from a shift, stretch or shrink, we're thinking multiply. Vertical, I'm thinking the entire function. So now I have something, entire function, I want to multiply by 3. And my vertical translation, so if I'm thinking my third thing, a translation is a shift left to right. Vertical is normal. Translation up, well, that has to come after the function. So I'm thinking everything stays the same as in step 2, but now since I'm going up at the end, I want to think add 5. And now we could simplify this down. If we simplified this, if we expanded it, we should get something that looks like 3x squared minus 12x plus 17. And if you check that out on your graphing, your calculator, you would see that those two things are the same. Now, letter B says we're going to do the same thing, but in the opposite order. And we're going to see how does this change. So again, we're still starting off with x squared. So the first thing we're going to do is now start with step 3. Step 3 says we're doing a vertical translation 5 units up. So just like we did before, I'm going to start this time by adding on the 5. Okay. Now step 2, if we're going backwards, says we're doing a vertical stretch by a factor of 3. So a vertical stretch, the stretch goes to the whole function. And if it's a factor of 3, I'm going to think multiply the whole function by 3. And our very last step says we are going to do a horizontal shift 2 units to the right. So again, if it is a horizontal shift, we're going left to right. Since we're going right, we're thinking backwards, and this is only affecting the x. So when we go to write this, be careful with your groupings. In x, x is the only thing that's going to be changing. So I want to make sure I group that in a separate set of parentheses. Now again, you could expand this. If you wanted to expand this and just check and see, would I be getting the same function? Check out, very similar, but different. Those constants are different. So order is going to matter once we simplify, once we take a look at our final answer. Okay, so that's the basics. We will practice some more of the graphical transformations in class, but I hope this helped.